Hi and welcome to video 5 in my video series on vectors and lines from Unit 3, Topic 2 of the Specialist Math curriculum. And in this video I'm going to talk about describing a line segment and just some of the little nuances that are brought up in some of the text sources, and it may form part of an external exam question or maybe in one of your internal exams. So in particular here, you need to remember that the definition of a line is basically a linear function. It travels infinitely in both directions. It can be in 2 dimensions or 3 dimensions. But a line segment is when that line has been restricted on both ends. So it's now just a small component of that line, so it's a segment. So if we restrict the domain of the parameter t or mu or lambda or whichever parameter we're using, it creates a line segment. And so we're going to look at an example now that might involve a line segment, and one of the really common ones is to determine the length of a line segment for a restricted line. And you can see here that we have restricted the length of the line lambda as being a value between -2 and 2. So it's a fairly simple question once you really nut it out. But just quickly to draw a diagram, it doesn't have to be much, but basically if I draw a straight line, I have no idea if that looks like what this straight line is. It's in 3 dimensions, so I guess it does look like this as long as you rotate your axis around appropriately. But this straight line will have an initial value, the t equals 0 value, and it will have a t equals -2 value and a t equals 2 value. So it's got those two endpoints that restrict the domain of this line, which creates a segment. So all we really need to do is find the vector at t equals -2 and the vector at t equals 2, and then find the difference between them, and then find the length of the line that's formed by the difference between them. It's actually not too bad. And in fact, you don't even have to really find the difference between them, because you can just see that this is a Pythagorean triple and start looking at the situation there. But I'm going to do it by finding the difference between them, because this Pythagorean triple is in 3D, so it's kind of more like this diagram here, which can create a bit of confusion. So we'll just do that difference between them, because that's how we find the length of a vector. And let's do it now. So first, I need to find what's happening at t equals 2 and t equals -2. At t equals 2, I'm not going to put a lot of work into this. I can see that my 2 and 3, I and k, exist the same, and I'm not actually even using 2. So let's change it now to lambda, and let's change these to lambda. Okay, so at lambda equals 2, I get 2i plus 2i, which gives me, so r lambda is equal to 4i. I get 0j minus 2j, so minus 2j, and then I get -3k plus 4k, which gives me plus k. So that's the position along the line at lambda equals 2. And so I can change this lambda to be r2. And then I have at lambda equals -2, I get r -2, and my calculations go as following. 2i minus 2i just gives me 0, and I'm just going to leave it off. And then I get 0j minus -2j gives me 2j. And then I've got -3k minus 4k gives me -7k. And so there is my position at r -2. Now, I can either do this situation. The distance formula doesn't matter which way you go, whether you look at this endpoint minus this endpoint or the other way around. But option 1 is to use the distance formula. So the distance is equal to the square root of basically the I1 minus I2 in whichever order, but you just have to be consistent with your orders sometimes. So 4 minus 2, no, that's incorrect because there's 0 on the second one. 4 minus 0 squared plus -2 minus 2 squared plus 1 minus 7, 1 minus -7 squared, and that gives me the square root of 16 4 squared plus 16 4 squared, and then plus 64 8 squared, and that is equal to the square root of 96. Or of course there are 6 16's in 96, so it's 4 root 6 if you like. The other option is to determine the distance based on the idea of R2 minus R negative 2 first, and that's equal to 4i. So this is now defining this as a vector in that direction. Actually, no, it's defining this as a vector in that direction. So I get 4i, along 4i, 2j, negative 2j minus 2j is minus 4j, and k minus negative 7k is plus 8k. And then the distance of R2 minus R negative 2 is just equal to the square root of 4 squared plus negative 4 squared plus 8 squared, which is equal to root 96 again, or 4 root 6. And you'll actually see that basically these processes here are the same, just a different way of viewing or a different order of doing it, but they're essentially the same process. So there you have it. That's how we find the distance of a restricted line segment that has been restricted by a set domain, or a set domain within the parameter, which in this case was lambda, but there are some variations on the types of questions you might be asked in describing a line segment. So that's the end of video 5. All the best.